Hello everyone. So tonight I'm I'm going to talk about the task from Python, which is this a mission planning and a control point determination. Control point planning. Sorry. So this is the task that I'm gonna read in Indonesian first. Sorry. So, buat perencanaan jauh terbang, ada kampus ITB menggunakan aplikasi Mission Planner. Wahana ini menggunakan fixed wing, kamera Sony 86000, overlap 80% dan side lab 60%. Terus dibuat juga pengukuran GCP dan ICP, GCP 8 dan ICP 6 titik. Terus base-nya dia temukan titik base, bisa data BM ITB atau BM di mana ya BM? Oke, aku tahu salah satu data BM cuma nggak apa. Dan buat tabel rencana pengukuran GCP dan ICP. Oke. So in English, sorry. So we have to build the flight path, the flight mission of this photogrammetric mission. So we're gonna use a VTOL fixed wing vehicle, UAV, air vehicle. So and for the camera, we're gonna use Sony Alpha 6000 with a 24mm lens. And the overlap and side lap within those path is 80% and 60% respectively. And for the GCP and ICP, we're going to have 8 GCPs and 6 ICPs, and we need to also determine the base that we're going to use, and it is chosen from the list of the benchmarks that are available in ITB. Okay, and we need to build a table too. Okay, so these two things, so number 1 and number 2, in real life it should be the other way around. Okay, we should always determine the control points first, and then we need to determine only after that we determine the flight path. And so that's exactly what we're going to do. So for this I'm going to use Google Earth Pro. But if you don't have Google Earth Pro, you can just use the web version of Google Earth. That should be fine. And we're going to open Google Earth Pro. We're going to zoom in on Bandung and our university, right? Where is it? Right here. Right here. I'm going to turn off the 3D models because it's annoying. Okay, so this is our campus. So first of all, we need to determine the so-called area of interest, the AOI. So the AOI is the area that we're going to photograph. So everything within the AOI must be photographs without exception. So we're going to determine. So in this case, the POI is our campus, our whole campus. So let's name it the POI. Okay. Sorry. Okay, that's the wrong way. Sorry. Let's move that to the side and just draw our polygon here. I don't know until when. I think this should be fine. Yeah, that. And I think we can just reduce the opacity a little bit so we can actually see what's going on. Okay. So that. For example, okay, this is an example. The POI. Sorry, the AOI. I'm sorry. Area of interest. Okay. I'm going to move this outside to temporary places, tempat sementara. Okay. So we have this, and then this is our AOI. Everything within this polygon absolutely must be photographs, and must be photographs within the specification. So over 80% overlap and 60% side lap. Okay, then we have this. Then we need to determine the base, tentukan titik base, determine the base point that we are going to be used from the list of benchmarks. So right now I don't have the list of benchmark. I think you guys have, but right now I don't. So I'm going to just use the benchmark that I remember from my previous experiences in ITB. So we have a benchmark right here in Plawit. So just put it at that. This is the base. And a good practice is to, okay, I think I'm gonna wait. I'm going to have to change the coordinate system to decimal degrees or degrees minutes seconds. So make sure you set the coordinates. Sorry, I use Indonesian here, but this is the degrees, minutes, and seconds. Make sure you set it on that. Okay, on the preferences. Okay, and then we can go back and mark our base. This is our base, and a good practice is to actually note those. Sorry, note those points. So we have the base here and our latitude and our longitude. Okay, so okay, we have the base there, and then we must determine our ground control points. So we need to have 8 here. So on ground control points, a good practice is to place those points on the edges of your area of interest. Why? Because the area that is controlled by those control points is only within the limits of the polygon that make up those points. Let me show you. Okay, for example, if I have GCP1 right here, GCP1, GCP2. Make sure you actually write those numbers down, okay? Because I think you need to on the task. So GCP2. I need to put it where we can actually put it. So don't put it like on top of buildings. No, put it where it is reasonable to put a control point there. So I think we don't have to. I think this is a great spot right here. It's clear. It's not obstructed by any buildings, any trees. And this one also, this is a parking lot in beside SBM. This is beside the JS building. Okay, we need to have 8. So this is GCP2. GCP3, sorry, 3 should be, I think down here should be adequate, but I don't think there's any grid spot in there. Just put it right here. I don't know. Okay, just put it right there. And GCP4, I'm gonna put it right. Okay, this is gonna be a little bit hard. Right? No, don't put it right there. This should be fine. It's not very clear, but I think clear enough. Okay. So those are the requirements for placing a control point. It should be where you can actually put a point. Put, for example, if you measure your GCP by, I don't know, GPS, for example, by GNSS, you need to put your points where you can actually do GNSS measurement. Okay. So you need to have a clear view of the sky, and it's not obstructed by anything. It's not, you're not obstructing anything. That's also important. So don't put it on in the middle of the road, for example. No. Okay, so on the geometry, why do we put the control points on the edges, on the corners here? Because the area that is controlled by these control points is only, sorry, I'm gonna use this one. This, on the area that is controlled by the control points is only this area, the lines within the lines that connect those points, those control points. Outside of it, it's not controlled. So if, okay, not controlled quotes, okay, so near, for example here, it's still relatively near the area here, so it's still, you know, a little bit controlled, but the further you got away from this square, the less controlled that point will be. So that's why we put it on the edges. It is to maximize our to maximize this area, okay, this polygon right here. Okay, I'm gonna erase that one, and let's continue to find 8 more GCPs. We already have these 4, sorry. So I think it's a great idea to put it right here. Okay, that's, I've been here, and that's not very a great idea to put anything. Okay, you don't need to follow my exact points. Okay, actually don't follow my exact points, because my exam will notice. So get creative on the placements. Okay, so GCP 5. I think we need to have sorry, that's the wrong button. GCP 6. So this should be fine. So we already have 4 on the corners. Okay, so a good practice usually is to put the rest of the points on like the middle of the edges right here. Like this is an edge, so put it around the middle. Okay, as close as the middle as you can get. And GCP 6, I think we put GCP 7 right here. GCP 7, right? Okay, don't put it in the middle of the road, as I said. So maybe just a little to the side in here. Anyway, is this possible? I don't think that's possible. Actually, that's fine. Let's put it here. Okay, that's GCP 7, and we 8, one more. Okay, GCP 8 right here. I think just put it right here near the sunken chords right here. Should be fine. Yeah. Okay, those are our GCPs. Okay, so don't copy my points. Okay, just be a little bit creative with the placements. Okay, those are the GCPs. Now we're moving on to the ICPs. Sorry, we need 6 ICPs. So let's do that. ICP 1. I'm gonna use I don't know, red for this. Yeah, orange. So the ICPs must be as far as possible from all the GCPs, but still within the AOI. So we're still within this polygon. See, as far as possible from the GCPs, but still within the area. So yeah, you can just guess on where you want to put it. So for example, I wanted to put it right here, this is far from 6, far from 1, from 8, and far from the base. So let's just put it there. For example, ICP1. Let's put ICP2 right here. ICP2. ICP3 should, I think, right, I don't know, here perhaps. ICP4. Wait a minute, okay, sorry. ICP4 should be, I don't know. Do we have a location right here? This is not a very great point, but let's use that. Okay, right here. Here. Nah. ICP4. We need 2 more. ICP5 should be. I don't know. We haven't had anything right here. So yeah, I think that's a great spot. And here in the middle of the physics department right here, ICP5, and the last one, ICP6. I'm gonna put it in front of the mathematics organization right here. Okay, so those are our points. So we have 8 GCPs, 6 ICPs, and 1 base. Okay, so a little bit of an extra thing. The planning, the determination of the base point should be other than what's specified here. So you have to use the available benchmarks on ITB. So the base should be where you can actually launch your vehicle. So in this case, we use a VTOL fixed wing vehicle. So VTOL stands for vertical takeoff and landings. That means it can take off, it can fly and land vertically, but it is also a fixed wing, so it flies horizontally. That's it. So this is not like a helicopter, not like a quadcopter drone, like the DJI drone that you usually see. This is actually a proper aircraft, a proper plane right here, airplane. So and it's quite big, 1 meter to 2 meters in length. So you have to put that into consideration. So this is why I chose this place. This is a quite wide place, so it has a relatively clear view of the sky, and it is located on a benchmark, and it can facilitate the takeoff and landing of a UAV quite easily. Other possible places would be right on this pathway right here from Plawit to all the way to Sanggan here, or I don't know where else. This one, but I think that this area is not available right now because there's some construction going on in there. So this should be fine too, but I don't think there's any benchmarks in there. So yeah, around here should be the best location for our base. Okay, so we have our ICPs, we have our GCPs, and make sure you take notes of these coordinates, okay, because you have to present it right here. So that the screenshot and the data that surrounds it. Okay, you can, for this one, you can just group it, gabungan gabungkan ke multigeometry. So what's gabungkan in English? Join it into a multi-geometry object. You can do it. So actually, don't do that. Actually, don't do that. Okay, sorry. But pisahkan multigeometry. Okay, don't do that. Okay, so I need to rename all this again. Okay, sorry guys, don't do that. So we have our base. This is our 8 GCPs, and there is our ICPs. Okay, sorry, shouldn't have done that. Just save it if you want. Okay, just do this. And how do you save it? Oh, you have to save it one by one. So this is save as, save place as, and for example this is the GCP1 or something like that. Okay, or you can just alternatively you can make a folder. So this is the GCPs, for example, and let's put it all on that folder, and you can just save this folder. Okay, that works better. Okay, gcp.kml. I'm gonna save it in right here, for example, GCPs, and you can have our ICPs here. Sorry, that's the wrong one. Tambahkan folder ICP 2 1 2 3 4 5 6. Okay, that's correct. And save as ICPs, and this will be our base. Okay, and also save our AOI, of course. This is our AOI. Make sure you save it on KML again. Don't use KMZ, because KMZ doesn't work in the other software that we're going to use. So KMZ is purely for Google Earth. So if you want to use other softwares, it's better to use KML. Okay. Okay, then this one, the step 2, is complete. So we're going to move to step 1. Yeah. So step 1, we're going to use something called Mission Planner. This is a free software. You can download it on the official website. It looks a little bit scary, but I mean it is. But you're just gonna have to deal with it. Okay. So Mission Planner is a software to plan, and also actually to control to control the flight of a unmanned aerial vehicle. So update now, no. So for example, this is when the software is connected to a flight computer, it's gonna show the altitude, the ground speed, and the attitude indicator. What's this called? Okay, the AI. And so we're not going to use the data because we're not flying right now. So we're going to move to flight planner right here. Flight planner. Okay. First of all, we're going to zoom into, of course, to ITB. ITB, where is ITB? Okay, this. And the first thing that we're going to do is to set our home point. So do you guys remember where our home point was? I think it's right here, okay, in Plowit. So right click on that and set home here. Okay, and that point is now set as our home. Okay, so if you accidentally click anything, just right click and clear mission. Sorry, I'm gonna zoom out a little bit. Okay, now we're going to import our AOI. So we right click on the screen and go to map tool, and select KML overlay and browse to the file, the AOI. Open that. Do you want to load this into the flight data screen? Of course, yes. Zoom to, yes. We have our AOI. Now the next step is actually to trace this AOI back, because I don't know why Mission Planner just doesn't want to actually import this. All it does right now is just showing the polygon. It doesn't actually draw anything. So we're going to have to draw it manually. So right click, select polygon, and draw a polygon. And we have to just carefully trace our polygon right here, the 4 points. Okay, now we're done. The next step is we right click on it on on auto WP. WP stands for waypoints. Okay, so now we're going to make our waypoints. Now, what are waypoints? Waypoints are point coordinates that the UAV must follow in order to complete the mission. Now what we're going to do is in order to do an aerial photograph in this area, we're going to have to make this maneuver, this zigzag maneuver, right, like this. So either north to south or east to west. So we have to do this over and over and over. So it's going to take a while to complete this. Why do we do that? Why don't we take like one large photo? Because as you have learned in Photogrammetry class, you need to actually have several photos of the same point in order to determine its location in space. So that's what we're going to plan. So right click on that, auto waypoints, and survey grids. Okay, so we have several versions here. Just use the first one, survey grid. Click on that, and we have this survey grid. So now what are our specifications? We're going to use a VTOL fixed wing. The camera is Sony Alpha 6000 with a 24mm lens, and the overlap would be 80%, the side lap would be 60%. We're going to set that camera. We have Sony Alpha 6000 right here. Okay. Now, before everything, make sure you check the advanced options here, because without those we cannot set the overlap, we cannot set the side lap, the lens, and anything. So make sure you check that first. Okay, we're moving right here. Camera, Sony Alpha 6000. Altitude. Now, the altitude depends entirely on the UAV, the particular UAV, on would it be able to achieve that kind of altitude, that high or that low of an altitude. So this is not an exact science. You have to actually know what you're going to fly, but in this case we don't. So just gonna assume that we're going to fly at a reasonable altitude of 100 meters. So about altitude, there are a lot of laws governing altitude. For example, near an airport, there's a kind of altitude restrictions. Why? Because actual commercial aircraft fly over those areas, so we cannot fly as high as for example, in a rural area, for example, where we can fly as high as we want. But in near an airport, and by the way, ITB is considered to be near an airport, the maximum altitude usually in ITB is around 120 meters. I think I'm gonna just set that 120 or 110, just to be, or just 100. Yeah, but the maximum legal altitude for this is 120 meters. Nearer to the airport, for example, if you fly in, I don't know, Kiara Condong, where it's right below the flight path of the aircraft, the highest altitude you can legally fly is around 50 or 60 meters, which is a lot lower. I have flown there. It's you can still hear the drone, because in 100 meters you generally don't hear a drone anymore. Okay, so we're going to move to grid options here. Grid options, just ignore everything else and focus on these two, overlap and side lap. So here it's already said the overlap would be 80%, and the side lap is 60%. But if you have any other values right here, you can just fix it right now. Now, what is the overlap? The overlap is the distance between subsequent photographs, between one photograph and the next on the same line. For example, I think we have like show the footprints. No, not the footprints, internals. So for example, these are the photographs, that the points in which the photographs are taken. So for example, here we take a photograph, here we take a photograph, etc. For example, if we lower the overlap to, for example, I don't know, 60%. Now see the number of photos decrease, but the number of lines here, the flight path, does not. That's because the flight path is controlled by the side lap. For example, if I set the side lap to 30%, now it's much wider between these turns. You can see that, right? Okay, we're going to set it to spec, so 60% and 80%. Now, a good practice is also to set the overshoot right here. Sorry, I'm gonna. Okay. Now the overshoot is there too. This points right here, because remember we use a fixed wing aircraft, and fixed wing aircraft cannot turn immediately. It has to, like, for example, if you're doing a U-turn in a motorcycle or in a car, you have to actually go a little bit more than the point, right? So you have to make a little bit of room for the aircraft to turn back in order. So when it turn back, it can follow. It can immediately follow this other line. So for example, here it must turn right here like this, and then goes back to the next line, because it cannot do like it can't do like that. It can't do maneuvers like those, like that. So set the overshoot, usually around 50 meters, but I've seen bigger. No, actually, just is 50 meters. Okay, for the overshoot. And I think we're missing something. Lead in the distance line overlap side like quarter with. Wait a minute, okay. Okay, that doesn't do anything. Heading hold, alternate lane, spiral options. Camera top facing forward. No. Oh, okay, set that in. Okay, so the focal length is 24 millimeters. Set that on the camera config. Okay, set the focal length to 24 millimeters. And okay, we have a few more lines here. And the flying speed. So the fixed wing aircrafts cannot fly slow. They absolutely cannot fly slow. So I think like the lowest I have seen for myself a fixed wing aircraft can fly is around 12 meter per second. I think I've seen 10, but it's like stall 5 seconds later. So 12 is the, I think 12 is the safe speed for it. So let's just say that 12 meter per second. Sorry. Okay, now let's see here. Make sure you take a screenshot of that. So the area is around 29 hectares or 291 hectares. So the distance is 10 kilometers. So, and the distance with images 30 meters. The ground resolution is 1.63 centimeters, which is very, very high. So I think I'm gonna just max the altitude to give it like, no, okay, that's 2 centimeters. So it's still good, but you know, we use fewer photographers. Let's see here. So here we have 585 pictures, which is a lot. If we move the altitude up by 20 meters, now we have 387 photos, which is a lot less. A little bit less. And most importantly, the flight time is just 14 minutes, which is very quick. It will take a photo every 1.3 seconds, and the minimum shutter speed is 1.1230. So this is what you're going to input to the camera later. Okay, just make sure you take a screenshot of that, make sure everything's correct, and click accept. So this is what you're going to present. Okay, we're going to present to on the PowerPoint, just this image right here. Accept that and save it to just put it right here, Waypoints. Okay, that's saved, and you can look at it. Look at the waypoints. Okay, it's not really readable by humans, but these are the waypoints. Okay, so that's it. That's for the tutorial. I hope you guys doing well. Okay, see ya.